In this lesson, we are going to learn how to apply the concepts that we have learned to solve GCE O-Level Examination Paper 2 questions. But before we jump into it, let's do a recap of what we have learned. The most important thing that you must remember for this module are the graphs of motions. When objects are at rest, the displacement time graphs and the velocity time graphs are horizontal straight lines, with the velocity time graph sitting on the x-axis because velocity is always zero when the object is at rest. Then we have also learned about objects traveling at constant speed, where the displacement time graph is an upward sloping straight line and the velocity time graph is horizontal. For objects traveling at uniform acceleration, where the velocity increases uniformly, the displacement time graph is a curve and the velocity time graph is an upward sloping straight line. For all these graphs, the gradient of the displacement time graphs will give the velocity, and the gradient of the velocity time graph will give the acceleration. The area under the velocity time graph will be the distance traveled. As for objects traveling at non-uniform acceleration, all these basic principles of the gradients and the area under the graphs still apply. Now let's get started with this question from GCE O-Level 2015. A skier slides down a slope as shown in figure 1.1. The values of the time t when the skier passes points A, B, C, and D are marked on figure 1.1. Figure 1.2 shows the velocity time graph of the motion with 4 points plotted. Between A and C, the acceleration is uniform. After D, the velocity of the skier is constant. On figure 1.2, draw a line to complete the velocity time graph from t equals to 0 to t equals to 10 seconds. I would encourage you to pause this video at this point and try out the question first before proceeding to listen to the solution. These 4 points on the graph correspond to the 4 points of the skier. Since it is given that between A and C, the acceleration is uniform, it means that the velocity of the skier is increasing uniformly. So based on what we have learned, for uniform acceleration, the velocity time graph is a straight line. Therefore, between A and C, it must be a straight line indicating that the skier's velocity increases by the same amount for every time interval. We are also told that after point D, the velocity of the skier is constant. When the velocity is a constant, the velocity time graph is a horizontal straight line because the velocity does not increase or decrease when it is constant. Now, from point C to D, the velocity is not constant, nor is the acceleration constant. So, if it is a non-uniform acceleration, then the velocity time graph will be a curve. In part B of this question, we are required to calculate the distance between point A and B and between point B and C. The distance is always derived from the area under the velocity time graph. So the distance will be equals to the area of this triangle, which equals half times 3 meters per second times 2 seconds, and that equals to 3 meters. Similarly, to find the distance between B and C, we need to calculate the area of this trapezium, and that is equals to half times 3 meters per second plus 6 meters per second times 2 seconds, which equals to 9 meters. Part C. The distance between A and D is 44 meters. The displacement of the skier is 0 at point A. On figure 1.3, draw a displacement time graph for the motion and state how your displacement time graph shows that the velocity is constant after D. Again, pause this video and try it out before proceeding. If you have tried it, compare your answers to this. At point A, since we are told that its displacement is 0, then the point on the displacement time graph is here. Next, for point B, remember that we have previously computed that the distance travelled between A and B is 3 meters. then this is the point on the graph. When you plot point C, be careful. Note that we are plotting on displacement time graph. Point C is the skier's displacement from starting point A to C. Yet the distance that you calculated in part B, that is the 9 meters, was between B to C. So you need to take the total distance travelled from A to C, that is 3 meters plus 9 meters, which is 12 meters, to be the displacement at point C. Many students make the mistake of putting point C at 9 meters, which is wrong. Then finally, for point D, it is at 44 meters because we are told that the distance from A to D is 44 meters. Let me enlarge this graph, and with the points plotted, we can sketch out the displacement time graph of the skier. Now the question also requires you to state how your displacement time graph shows that the velocity is constant after D. Here's another exam tip. When you do a long question like this one in examination, be careful not to miss out any parts. Some students forgot that there is a second part to this question after they sketch out the graph. So remember to check that you have finished all the parts of the question. Now, for the answer, you should say that after point D, the graph is an upward sloping straight line because when the velocity is constant, the skier travels the same distance with every second and its displacement increases uniformly. Paper 2 questions are usually very lengthy and it appears difficult when you first read it. However, you must never be intimidated by it. If you have understood the concepts in this course, you should be able to solve the questions. You just need to stay calm, read the question carefully, and you will solve it.